Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science just like I did. Today we are going through another example from the LeetCode series. In particular, this time it'll be a medium problem in the array category, and it's called Subarray sum equals k. So let's dig into it. A few just slight clarifications within the problem set. It's fairly short. You are given sort of an input array and it has integers. So something really important is that those integers can be negative and the k itself could be negative, even though kind of in the examples we're only seeing sort of simpler positive aspects. And then we do want a continuous set of subarrays to equal that k, and what you're returning is actually how many of those subarrays you managed to find. Nothing else, not the indices, not just if you found it or not. And something to keep in mind is basically, and you sort of see it in this particular examples, it could be from the beginning and then sort of up to however many, but it could also be starting not from the beginning onwards, and more importantly also it could be a singular piece of integer within the input nums. So there is quite a few sort of brute force ways of going about this, and you could maybe do a couple of for loops. I mean, you could even do 3 for loops where you're going through to sort of find what you need, but let's try to be smart about it. And here there's a concept that it's almost sort of playing with the numbers a little bit that's going to come in handy. So what's the trick, like I call it? Think of, and at least in my video for toSum, I talk a little bit about this concept of doing a minus. So in toSum, I think we had a target, and then I minused it from our input array, so that we say, oh, if only I had that difference, then if I do encounter it, then I'm sort of golden. In this particular case, what we're having is something somewhat tangential. I found certain examples to do a really good job at it, so I jotted a few things down here. For example, this first one that we're looking at, it's a little bit long, but I think it'll do the job nicely. Let's think about this. So if our target is the number 4, then how can we get number 4? The idea over here a little bit, and we'll get to it, is to only continuously be adding up the numbers that we're looking at, and that's what I'm calling a cumulative sum, right, over time. Nothing else. That way I really kind of keep up with the sort of only an O event, once through the array. And then what do we do? Well, clearly, 1 alone is not going to get you k, in this case 4. 1 plus 2, it gets you 3. And then finally, once you add a 1, it gets you a 4. Okay, that's fine and handy, all right? Like we only looked at this particular direction, nothing too fancy, but nonetheless, right? We get here and we're keeping a little counter for the summation of how many subarrays we've encountered. Okay, so sure. So in this particular case, like we add a +1 to that. That we're gonna return at the end. Okay, fine. What's more interesting is as we continue, and this is where the difference trick, I'm going to call it the Diff Trick, is sort of the category I'm going to put all of this in, is now let's assume, let me pick maybe like purple. So let's assume, okay, I'm continuing, right? And here's something that should catch our eye. So far I've counted, and apologies here, this is a 4. So far, what did I count? Up to here, I've got a little 4, so that's fine. So I've got a little 4, and then to it, we're adding a 3, right? So really, here, the cumulative sum is going to be 7. Okay, so 7 is really not useful, right? However, we could totally see ourselves that this section here does give us a 4. So where does this differential trick come into play? Well, 7 minus k, minus the thing that we want, gives us 3. So similar to the two-sum idea, we're thinking, if only I had previously encountered some kind of sum, consecutive sum, right? We're still in the word of like a consecutive sum because that's sort of consecutive or continuous, if you'd like, sum. If only I had seen something that actually added up to 3, because I know that if I had seen something that added up to 3 and I add to it my value k, which equals to 4, then I'm getting this sort of broader cumulative sum of 7. So that's the situation we're in. And so if we were to write it in a little more cleaner fashion, then really what we have is, and I can write it just at the bottom right so that we're not doing it too many times. So basically we said up to here, or in our particular case, the one that's going to matter, up to here, I've actually already encountered a 3 as a cumulative sum, right? The one that I'm kind of calling over here. Cumulative sum of 3. And then if I add to that, so that's from beginning to this point. And then if I add to that, or if I look at the cumulative sum up to here, then that gives me a 7. And because I'm looking at the difference between them, then that's giving me a 4. So we know that up to this index and then starting from it to this one, we do have something that adds up to 4 and is therefore a continuous subarray. So how do we code this up? Where the idea is to use a hash table. Lookups are great there, but the sort of central thing is, okay, what do I put in this hash table? And this is this is what we're seeing over here. What do I put in there? What really matters is this concept of summations, right? So if I did have a way of knowing, of saving, okay, I've seen one way, so this is my key. 3 would be summation. And if you want to be even more precise, it's a continuous summation. And then how many times I've seen it. So the value is a frequency seen. Now, someone might ask, okay, why are we also looking for a frequency? Well, the idea is, and we sort of see it in this additional example I had here. Say we had, in particular, let's clean it up a little bit. If we had -1, 1, and 4, that one is kind of funny, right? Because it kind of cancels itself out. So there, -1, 1, and 4. Technically, it's kind of ironic, right? And then again, if the k is 4, clearly, I mean, obviously you've got this one alone. But, so if we were to give them indices, then if you want to be really precise, this one would be sort of a kind of like a 2 to 3 or something like that, basically. And And then the other one, because it's not inclusive usually, I guess you could do it like this. And the other one, ironically, is also 0 to sort of 3. And some people prefer also to write these things as this so that you have the inclusivity, so whatever works for you. But basically, and it's kind of funny, right? Because it's really just these two add up to 0. And let me put them in a different color so that it doesn't mess with the index. But these two add up to 0. And if you add to them plus 4, that's also going to work out. But if you looked at the 4 alone, then it also works out. So this summation thing, how is that going to work? Well, let us maybe walk through the code once and for all at this point in time. Here we go. And also just for sanity check, I'll show you these couple of examples, and then we do one last walkthrough, and hopefully that made sense. And feel free, as always, to put any comments or questions where you'd like to. Right here, and then this one is sort of also an interesting one to play with. So also a 4. And one last one that I find particularly interesting is, for example, 0. And if the k that you're looking for is a 0, then technically your answer would be 1. That's another edge case to keep in mind of. So we see that all of these work. Okay, so I guess final thing to do is to walk through the code, and hopefully that will clarify any ambiguities. So we come in. This one we already spoke about. That's going to be just a counter of how many continuous subarrays we're encountering that do work out and equal to k. Great. Now the second thing we do is we're going to have this cumulative sum. We explicitly use 0 because remember, actually fantastic, the one that we're looking at right now here, it's the element itself alone that actually does equal to k, and therefore we do see it once, and our little subarray part is going to be incremented once, and that's how we get the correct result of 1. So it's important that we're starting on purpose in 0. Okay, so we go in and say, all right, right now my little dictionary, for the lack of, or to avoid any specific terminologies, which I'm calling here my lookup, basically, table, is going to have 0, and that has been seen once. So we've got that. Okay, sounds good. And then we go in. We're going to loop only once. So this is we're gonna stick to our little O of n notation, and we're only creating the dictionary in this particular case. So we go in, what do we say? All right, well, now is when the fun starts, right? So over here, if we're looking at this particular example, then here we go, 4 and -3. Then we're over here, and we are adding the 1 to our cumulative summation. So right now, that's going to equate to 0 plus 1 equals 1. Great. That's for the cumulative summation. Okay. So we move in and say, all right, let me see if I do happen to have that. I don't, right? I do a 1 minus k, that's totally not equal to number 4, which is sort of what we were looking for here for that particular use case. So we move on, so we're past this part, we go in here. Well, let's make sure to increment our dictionary as we'd like to. So do we have that cumulative sum of 1 in our dictionary? We do not. So let's add it, so number 1, and then we increment by 1. Then we keep on going. This time we see the number 2. So cumulative sum becomes 1 plus 2. That's equals to 3. Same thing, 3 minus 4. That's not what we want. And i.e. that's not something that we have encountered. Therefore, we just add it to the array. And we've seen it only once. And we keep on going. The next one is number 1. So here it's going to be 4. 4, it's starting to get interesting, right? So we come in here, we already incremented. So now we do 4 minus 4 equals 0. Well, have we seen a 0? Yes, we have. And the reason, and that was the very first one we started with. And indeed, it's kind of exactly what we want, because it's sort of saying from beginning to where I've reached right now, you know, basically chopping off anything before, which is sort of a 0, I am getting to a 4, and therefore we're pretty good. So when we encounter that is sort of when you increment the piece that you're putting at the very end. Now, why do I have it this way as opposed to just, for example, incrementing by 1? Well, what we could have is sort of what we looked at over here. You could have more than one way of getting to the solution, for like this, or you've got things that cancel out. So we're trying to count all of the, i.e., you know, you get a 0 and you're adding a 4 to it, that's still a 4. So you might have multiple examples where you have more than one way of accounting for that particular summation. Another good example, which they have on the website, is, for example, if it's all zeros and your k is 0, then same thing. You have so many possibilities of gathering zeros, right? It could be just this one, i.e. the one leftmost, or it could be both of these, or it could be all of them, or it could be from here to here, etc., etc. So that's what's happening over there. And we basically continue. So then we move to the next summation, and that's going to be a 7. And we do a minus, and indeed that's going to get us this chunk. And we keep on going. And we'll have a similar situation over here where we'll also get yet another additional instance. So I'll pause there. I think another nice piece to look at for if people have an interest is sort of an illustrative example that they have on the website, where basically this is exactly what we were going through. You know, you start out with your 0, you have one instance of it, now you move to that first element of your nums array, you're only seeing it once. You move on to the next thing, 3 plus 4, that's 7. 7 you've only seen it once, but then you do the usual kind of checkup over here and say, well, 7 minus 4, or minus, let's see, what's the k over here? The k is a 7. And so yeah, if you do the minus, then you'll say, well, if I only had a 0 that I've seen in the past, then that means that in and of itself would work out. So here we're up to here, right? So that gives us basically from the 0th element, first and second element, you know, gives us that answer. And then furthermore, once you reach this one in particular, while the summation together, because it's a 7 plus a 7 is a 4, you say, well, if only 14 plus 7, I have a 7. If only I have seen a 7 before, then I know that this works. So same thing. You know that 3 plus 4 gave you a 7 because you already calculated that and added it to your mapping, sort of what I'm calling here my sum lookup. So basically what this tells us is this summation 3 to 4 gave us the 7, and when we added another 7 to it, basically you know, that is equivalent to a k, and so it's really just this element that makes up the k that you're looking for, and you kind of keep on going. So I hope that was helpful. As usual, feel free to put any comments or like specific problems you'd like to go over, and if you like the content, please subscribe. Thank you very much.